right, so 6.1 is a continuation of statistics, and we're going to talk about measures of dispersion. All right, so range is another way to calculate something about a specific state of data value. So the range is the difference between the largest and smallest data values in a set. So if you wanted to find the range and height of inches in this chart, so we would look for height of inches, and your largest would be 107, and your smallest would be 26. And so 107 minus 26 inches would be 81 inches, and that would be your range. All right, standard deviation is the distance of each value from the mean. So how far away is your value from the mean? So if x is a data value in a set whose mean is x bar, and you guys, this, when you see x bar, that means mean. Oops, let me go back. This means mean, okay? Then x minus x bar is called the standard deviation from the mean. So x minus x bar equals your standard deviation, okay? And you'll also see this standard deviation looks something like that in your calculator for some of you. So here is the formula to find the standard deviation. This means the sum. So what you're going to have to do is you have to subtract your data value minus your mean, and then you square each value, and then you add them all up. And n is the amount of values in the sample. Okay? And then you divide those n minus 1, so take away 1, and then you take the square root of it. So we're going to do an example. All right, so if you're trying to find the standard deviation, the first thing you have to compute is the mean, which is the average, right? This should be a little bar above the x bar. Then you would find your x minus x bar, and you square each value. Then you add up all those numbers, and then the last thing you would do is divide it by n minus 1, and then take the square root of it. So let's do the first one. So the first thing you need to do for the first set of data is find the mean. And let's compute the mean. 8 plus 4 plus 7 plus 6 plus 5 plus 5 plus 4 plus 9 divided by 1, 2, 3, 4, 5, 6, 7, 8. 6. So your mean is 6, okay? All right, so we have the mean, so you're going to write your x value, and then x minus the mean, and then x minus the mean, all of that squared. So I'm going to write 8, 4, 7, 6, 5, 5, 4, 9. Oops, let's go back. Let's write it here. And the mean is 6, right? Okay, let's do it here actually. then let's go. Our beta 847 655 49. Okay. And so then your mean, remember, was 6, right? So you would do 8 minus 6 equals 2. And then 4 minus 6 equals negative 2. And then 7 minus 6 equals 1. 6 minus 6 equals 0. 5 minus 6 equals negative 1. 5 minus 5 equals 0. 4 minus 5 equals negative 1. And 9 minus 5 equals 4. All right, and then the last column, you're going to take this number and you're going to square it. So 2 squared is 4. Negative 2 squared. Remember, negative 2 means negative 2 times negative 2, which is a positive 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is a positive 1. 0 squared is 0. Negative, wait a minute, 5 minus 6, it should be negative 1, sorry. Negative 1 squared equals 1, because these are the same number, right? So they should have the same answer. And then 4 squared is 16. Okay, so we just did step number 2. Now you add up all the squares. So we add up 4 plus 4 plus 1 plus 0 plus 1 plus 1 plus 1 plus 16. All right, so that's 8, 9, 10, 11, 12. 12 plus 16 is 28. All right, so the sum down here would be 28. So that goes on top. And then n minus 1, how many terms are there? There's 1, 2, 3, 4, 5, 6, 7, 8 terms. So n is 8. That's how many in the data set. So 8 minus 1. And then you take the whole square root of that. So this is going to be 28 divided by 7, the square root. 28 divided by 7 is 4. So then you have the square root of 4, which is 2. So your standard deviation for the first question is 2. And you'll do the same thing for number 2 and the same thing for number 3. And there's plenty of examples of these in your book as well. All right, so another question for frequency distribution, you would do this, and then you do the same thing, and then you have to multiply it by how often it occurs, which is your frequency, right? And then you do n minus 1. And this is the case when you have a lot of repeating numbers, so it just makes your life a little bit easier. So, for example, like this one, before we look at this one, I would look at a problem like in your book. Let's see, hold on just a minute, what page? Pause it. All right, so if you were to look at on page 337, example 3, right? So it gives you 37, oops, let me go back. These are your numbers, 37, 39, 39, 40, 40, 38, 38, 39, 40, 41, 41, 39, 41, 42, 42, 44, 40, 40, and 41. So notice you have a lot of the same repeating numbers. So we're just going to write one of our numbers. We have a 37, a 38, a 39, a 40, a 41, a 42, and a 44. And then your F is how often it occurs. So how many 37s are there? There's one 37. There's 38s, 1, 2, 2 38s. 39, there's 1, 2, 3, 4, 5 39s. There are 1, 2, 3, 4, 5 40s. There are 1, 2, 3, 4 41s. And then 42, there are 2 42s, and then 1 44. Okay, so we need to find the mean. So we add all these up and divide by how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So n is 20. So when you do this, you should get, you add all those up, you get 800. So your mean is going to be 800 divided by 20, which is 40. Okay. So then I'm going to go ahead and subtract. So you're going to do 37 minus 40. You get negative 3. 38 minus 40 is negative 2. 39 minus 40 is negative 1. 40 minus 40 is 0. 41 minus 40 is 1. 42 minus 40 is 2. 44 minus 40 is 4. Now here we're going to square them. So negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 4 squared is 16. Okay, so with this one, now we're going to take that and multiply it by your f. So it's going to be x minus x bar squared times your f. Again, this is on page 337. All right, so I'm going to multiply those. So 9 times 1 is 9. So 4 times 2 is 8. 1 times 5 is 5. 0 times 5 is 0. 1 times 4 is 4. 4 times 2 is 8. 16 times 1 is 16. Okay, so 9, 8, 5, 0, 4, 8, 16. And I did mine a little bit different in the order just because I like to have these side by side so it's easy to multiply them. All right, so then you have to take the sum of these. So you add all those together and you get 50. And we said there was 40. 20 numbers, so 20 minus 1, and then you take the square root of that. So that'll be 50 divided by 19, the square root of that. And you should get approximately 1.62. So that's your standard deviation for that. Okay. All right, here's another example. I'm not going to do this one, but this is like on page you could do this one. I'm trying to see what page this is. I'm not sure. All right, but anyway, you guys could try that one on your own. All right, so for its data set with a mean x, remember there's a little bar on top of that, and standard deviations, we can define the coefficient of variation. Okay, and the coefficient of variation is just how far off are you from the mean? So, for an example, if you have a group of preschool children, this is like an example, page 339, and you're talking about the weight, and you want to see how it varies from the average, right? So you have the weight of preschool children, and then you have the weight of NFL football players, right? It gives you that the standard deviation for the preschool children is 3. So that means it's only about 3. It's 3 off from the mean. And then the mean is 30. If you want to find about the percent of the coefficient of variation, you would do 3 over 30 and times it by 100. And you end up with about 10%. This is for preschool. And then if you were looking at football players, the football players, their standard deviation is 10 over out of 300 is their mean. Times it by 100, and they have 3.3%. So, because the coefficient is larger for the group of preschoolers, we conclude that there's more variation in their weights than in the weights of the football player. So because this number is bigger than this number, there's more variation in this. So that means their weights differ a lot more than the football players. Okay, so this is what I was just showing. The coefficient of variation for the weight of a group of preschoolers is 3 divided by 30 times 100, which is 10%. Whereas the group of NFL football linemen is 10 divided by 300 times 100, which is 3.3%. So because this percentage is larger than this, there's more variation in the group of preschoolers' weight. All right, so then you guys can easily find different coefficient variations for different things. You would have to be able to find the standard deviation and the mean. And this is again on page 339 in your book. And that's pretty much it out of this section. So please practice this homework. I'm not going to take it up, but this is for your practice. And most of these are odd, so you can look at your answers in the back of the book. And again, if you have any questions, please email me and I will be happy to help you.